Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Sarah binti Ismail. Metric number 1240825 from Group 5 will be representing question 7 for our assignment 3. First, I will read the question. Farah purchases a commercial retirement annuity plan at a total premium price of RMX that guarantees her a target yield rate of 5% effective. This specialized annuity is structured to distribute a total of 10 payouts spaced out at strict 3-year intervals. With the first payment disbursed immediately on the date of purchase, the initial payout is set at RM100 and each successive scheduled payment is agreed to be 5% greater than the previous one. Determine the initial purchase premium as.
Let's begin by analyzing the timeline layout. The problem explicitly states that the first payment is disbursed immediately on the date of purchase. This keyword tells us right away that we are dealing with annuity due, meaning our cash flows occurs at the beginning of each period rather than the end. So that's why we start the payment at 0. Furthermore, the total plan consists of 10 payouts that are spaced out at strict 3-year intervals. Because of this 3-year gap between payments, our timeline does not advance by single years, but instead it jumps in multiple of 3. Therefore, our first payment is 0, 3, 6, 9, 12, until 27 for a total of 10 payouts. Then, moving on the question, it is said that the yield rate is 5% effective. So, this is very important step because we need to adjust our interest rate. Since the question provides a target yield rate of 5% annual effective, we cannot use the 5% directly because our cash flows occurs every 3 years rather than annually. So using 5% directly in a standard compounding frequency will be a fundamental mistake because the compounding frequency must match the payment frequency. So in order to fix this, we have to calculate an equivalent 3 years effective interest rate, which will be defined as J. By setting up the equivalence equation, 1 plus J is equal to 1 plus I power of 3, and substituting our 5% annual rate, we will find that this gives us a 3-year period rate of J is equal to 0.157625. So this rate represents the actual interest accrued between each individual payment interval. And then from this question that we read, this is not a level annuity. It is a geometrically increasing annuity because the initial payout is fixed at 100, but each successive scheduled payment is agreed to be 5% greater than the previous one. Means our growth rate is 0.05. On our timeline, the first payment is 100. The second payment at year 3 is 100 times 1.05 power of 1. For the third payment at year 6, it is 100 times 1.05 power of 2. And then we do this until the final payment at year 27. That will be 100 times 1.05 power of 9. And then to pull everything together, and since we need to solve the purchase premium X, we need to calculate the PV at t is equals to 0 by discounting all time payments back to the origin. This forms a geometric series where the common ratio R is the growth factor divided by interest discount factor, where R we can express is R equals to 1 plus G over 1 plus J. By substituting our initial payment R equals to 100, number of period equals to 10, and our calculated ratio into the geometric series formula, we can actually compute the exact value. This breakdown ensures that we account for both the changing value of money over the 3-year intervals and the compounding growth G of the retirement payout seamlessly. And then we substitute the value of G 0.05 and J 0.157625 into the formula to solve PV. And then by solving this equation, we can get PV is equal to 670 ringgit and 22 cents.